Hey, I'm Æyers, and this week I'm going to be doing two puzzles and talking out loud while I do them. Just because Chloe thought that would be an entertaining video. So here we are. So this puzzle is called Circle Math, and basically what it is that each letter is a number 1 through 9, and there should be 9 circles. Yep, so that each number 1 through 9 is a sign. So if B is 3, none of the other letters can be 3. Then the numbers in the overlap are what those two letters are added together. So like if we know B is 3, that means A is 4. That sort of thing. And this is all we get. So I'm going to start by writing out all the numbers. Just so that we can cross them off as we go, that sort of thing. Then, the next thing to look at is what these numbers are really telling us is that the letters next to them can only be certain pairs of numbers. So, for example, if your number is, like if we had 17 here, then we know that 8 and 9 are the only possible number combinations that A and D could be. We don't have that. That would be entirely too useful. But yeah, so 3 and 17 are the lowest and highest possible numbers that could be in these sections. And the closer we are to those extremes, the more information it tells us. Because if, like 10, for example, is the least helpful thing, because we have all of these pairs that those numbers could be. But for 7, for example, you've only got 1, 6, 2, 5, 3, 4. So there's only 3 pairs that A and B can be. That made sense. 15, on the other hand, is on the high end. So you can kind of start at 7 and 8, and then 9 and 6. So there's only 2 pairs that these letters can be. So I think what I'm going to do is I'm just going to start writing down those pairs and see how it goes. So 15 is 7 and 8 and 6 and 9, and that's it. 7, I already did these, so that's going to be 3, 4, 2, 5, and 1, 6. 8 will be 3, 5, 2, 6, 1, and 7. 9 we have several of, but it's going to be a lot of them. So 4, 5, 3, 6, 2, 7, 1, 8. So I can copy those down here. 5, 3, 6, 2, 7, 1, 8. And then we've got the 2 10s. So then we have the 4 sets again. But they're slightly different. So 4, 6, 3, 7, 2, 8, 1, 9. 4, 6, 3, 7, 2, 8, 1, 9. So that's the easy part of just looking at it, writing some things. But now we have to try to find somewhere to start, which is hard. So I'm tempted to start with like D or G because there's only 4 options of these numbers for them to be. So for example, G can be one of these four, but it also has to be one of these four. So, for example, G can't be 9 because it's not in this list, but 6, 7, 8 are all here. So, in G we can write 6, 7, 8. And if G can't be 9, then the other side of that pair can't happen here. So, because if this isn't 9, this can't be 6 anymore. So now we only have 3 options. So this is going to be 7, 8, or 9. Which narrows things a little bit. That's not terrible. Let's just keep doing that, I guess. So this can be everything but 5. So H can be everything but 5 over here. And this is everything but 9 over here. So that crosses out or I just thought of a better way to do it. So we know G can only be one of these 3. So we can look at the pairs here, and we know that H can only be one of those 3 numbers. I don't know how to make that make sense. So 6, 7, 8 are what G is going to be. So G can't be 4 or 5, and so this pair no longer makes sense. We can cross that out. But if G is 6, 7, or 8, then H has to be 1, 2, or 3. So we've got that. Now we can do the similar thing here. So if I is 1, 2, or 3, this pair is not going to be 4, 6, which means we have 7, 8, 9 again. And that's where our beautiful chain ends. But we can do a similar thing here. So we're just going to start that, work our way down, and then see what we have. So 1, 2, 3, 1, 2, 3, and then we have 5, 6, 5, 6. But we don't have. So 4 is in this set, but not in this set, so you can cross it out. And 7 is in this set, but not in this set, so we can cross it out. So then this can be 1, 2, 3, 5, 6, which means A can be, so similar to what we did down here with the 9. So if this can't be 4, then A can't be 3. So it'll be 1, 2, 4, 5, 6. Which is a lot of options, but we're working on it, all right? This is going to be, so 1, 2, 3, 5, 6. Jeez. Okay, so this isn't going to be 7, so this isn't going to be 1. But otherwise, it can be 2, 3, 5, 6, and this can be 7. All right, so now we're working with this list over here. So we got neither 1 nor 8. So we can get rid of that set. So we have both 2 and 7. So E can have 2 and 7. 3 and 6 we have both of, so we can have both of those. And then this has 5, so this can have 4. But because this doesn't have 4, this can't be 5. I'm hoping that makes sense. I'm just going with it. Now we have these to compare with this list. So we've got 4, 6, 3, 7. We have that. And then 2 is over here, so this can have 8, but not the reverse. And then we don't have 1 or 9, so that's not going to happen. Okay. So let's look through here, see what we can do next. So let's underline the rare numbers. So we've got only 2 9s. Let's do that with a different color. I shouldn't have been using black this whole time. It's a disaster. Okay, so we've got only 2 9s. That's rare. We've got, what, 3 1s? That's not bad. But we have this string of causality, so we can do some guess and check. So because there's only 2 options for 9, let's see how that works. So if this is 9, we'll just do it, I'll do it far out. So if this is 9, this has to be 6, because this is 15. If this is 6, this has to be 3. If this is 3, this has to be 7. Okay. That seemed to work out pretty well. Let's do a similar thing for blue. So if this is 9, then this has to be 1. If this is 1, this has to be 8. If this is 8, this has to be 7. Okay, so we've got 2 pairs of numbers that do work down here, but it's going to have to be one of these two. It's going to have to be one of these 2 options. So we can go through now and cross out the ones that aren't this. So D can no longer be 8 because the 9 is either going to be here or here. So, and we've mapped out both of those options. So this is not going to be 8. This is not going to be 7. This is not going to be 2. And this is not going to be 8. So, with any luck, that gave us a new rare number. So either this has to be 8, or this has to be 8. So let's underline that. Either this is 8, or that's 8. Okay. So we can try to get lucky over here. So if we start filling in, pretending this is 8, and then we run into something where that's impossible, then that means that this can't be 8 anymore. Then we know this is 8, and that locks in a lot of stuff for us. Because we'd rather this be 8 than this is 8, because that would tell us a lot of things. So we're going to take that gamble. It might not pay out, because if the 8 here, I think I confused myself. We want the 8 to be here and not here, but we need to prove that. I'm not sure I'm right about this. Because if this is wrong, then we know these are right, but that doesn't tell us much about that side. That'll knock out a row of numbers, but... let's try it. Screw it. Okay, so we're saying this is 8. I guess I'll just write it in green. So if this is 8, this has to be 2. If this is 2, that has to be 7. If this is 7, that has to be 1. If this is 1, this has to be 6. Okay, so if this is 8, that means this is not 8, which means we have 9, 6, 3, and 7 over here. So 7 and 7 can't coexist. So that means we know that this setup doesn't work, where the 8 is here and the 6 is here. So that means that the green numbers are incorrect and the blue numbers are correct. So that's cool. We're going to go through, mark through that. Okay, so now we've got, these are confirmed numbers. and we can cross out some of these. 1, 7, 8, 9. So 1, 7, 8, 9. So now we can go back through all of these and cross out all those numbers. Hopefully that narrows things down for us. So 1's gone, 1's gone, 7's gone, 7's gone, 8's gone, 7's gone. Okay. I'll admit that left us with more numbers than I was hoping for. When I've done puzzles like this in the past, I haven't had two separate sections like this. So when I got this far into it, the whole thing just kind of solved itself. But now, we can't do that, can we? Okay, so 3 4s, 3 5s, 6 can be anywhere. Okay, so let's look at the pairs then, shall we? Because we need 2, 3, 4, 5, 6. Okay. We're going to have to do more guess and check, which I'm not happy with, but we're doing it. So what we're going to do is we're going to write out, probably down here, A, B, C, E, F. So, I guess what we can do is cross out any pairs that are now illegal. So like 1 and 6, we can't have the 1 here, so that can't happen. 1 and 7, can't have that happen. Neither 7 or 8 can happen. Oh, and there's some up here. 7 can't happen. So now we know that these are going to be 4 and 6. That's where these are going to be. So, let's pick a new number. So these are either going to be 4 or 6. If this is either 4 or 6, that means if E is either 4 or 6, that means C is either 5 or 3. If this is either 3 or 5, this is either 3 or 5. And if this is either 3 or 5, this is either 2 or 4. We have 4 crossed out for some reason. For this one. Okay, so this is either 2 or 4. But we've solved it now because we know 4 is going to be in either E or F because it has to be this pair. So 4 is definitely going to be here somewhere. We don't know where yet, but we know it's going to be in here. So that means that we know 4 isn't going to be here. So blue is our confirmed color, so we'll just go with that. So we know this is going to be 2, which means that this is going to be 5, which means this is going to be 3, which means this is going to be 6, which means this is going to be 4. And then, that should be all our numbers. And we can check if we're right. Hopefully we're right. 1, 2, 4. What is it called? Circle math. Circle math. Oh, we never figured out D. No, we did. It's over here at 7. Nice. Nice. We got it right. Look at that. Incredible news. So this puzzle is called On the Surface because hopefully you can tell what I have drawn here is the surface of like a cuboid kind of object. I tried to draw in some shadows to try to give like a little bit of hopefully you understand what's going on. We'll see. Basically, all of these pieces are gonna fit onto here. So like we've got, I didn't draw the squares. Ah, one sec. We also have two squares. So we've got two squares over here. Always did, always will. And they're gonna go here. Because the rest of these are part of bigger shapes. So like all of these are gonna be that kind of dealio. And then we've got a couple like these are gonna be these. Somewhere they're gonna slot in. And so like this one we know is gonna end up here because that's the only place for it. We couldn't, for example, put this one here and then split this 4 and 2 into this shape and this shape. We're not, none of that. None of that. We're just putting the shapes into somewhere they fit. Yeah, that's what happened. So, how this puzzle works is that if you trace the three-dimensional path from one letter to that same letter, so across here, down here, to the other A, that path is going to add up to 42, as well as all the other lettered paths, or all of them are going to add up to 42, if I'm right. Yeah. So, I have no idea how hard this is going to be. Hopefully it's in between just math and boring everyone to death. We're going to get started. So this 6 is going here. So we know that. That's easy. You can cross this out. Then we know there's only one of these, so it's going to have to go here. This is going to be 7 and 8. We know that. So we know 10 and 13 are going to be here, so we can just kind of like write in like, but that's not going to be particularly useful until like later, probably. Here's an idea. So we know that these 3 are all going to slot in there, right? So and then from B to B adds all of them up. So let's add up all of these. So we'll just do that. So we've got, what, 10, 10, 12. So we've got 32, which means that these two numbers have to add up to 10 in order to get us to 42. So is there one of the cubes, one of these 7, where the top side and the right side add up to 10. And hopefully there's only one of them. So 6, 12, 13, 17, 6, 10, 17. So we know this one is going to go here. We don't know the order of these yet, but we know that, which one was it? This one goes here. And that gives us this full row, which is cool. Wow. But what a roundabout way to do that exact process I just did, but for here. But, you know, we got there one way or another, so sue me. Approximately. What is it, 17? So we can double check our work if we want to by adding up this. So 15 and 10 is 25 plus 17, bam, 42. Cool. What next? Well, the K row is pretty short, so maybe we can figure something out about that. So we know, for example, that this is either going to be a 4 or a 2. And we know that this is either going to be 10 or 13. So then, I guess we can get a maximum and minimum. That'll be better than nothing. So if these are the high numbers, that'll add up to 17. And if they're the low numbers, it'll add up to 12. Yeah. Okay, so then this needs to add up to something in between 30 and 25. Does that check out? I think that checks out. Okay, so then we're adding up the front and the right side of the cubes to see if they add up to somewhere between 30 and 25. So, nope, 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 nope. 25. It's a miracle. Okay, so thank goodness there's only one of them, am I right? Okay, so 7. But in addition, it was the low end, it was 25. And so that means that we need 13 and 4. That's what we need. Oh. Why am I doing this? I have a smaller eraser. So this is 4. This is 13. And this is 10. So we've placed the squares now. That looks like a 16. Don't do that, Alex. Okay, so we've got these. We can't actually cross off either of these because we still don't know whether it's an 8 or a 10. But, you know, we know 2 is going to be in one of these two. I don't think we can put that to use yet necessarily. So let's do G. So this is the G path. So we've got, let's erase some of our working numbers, shall we? Try to keep it relatively clean. So we know this is either going to be 8 or 10. And then we've only got 2 more. So say this is somewhere between 30 and 32. That checks out. Yeah. So this path so far adds up to 30 or 32. So combined with 42, this is going to be somewhere in between 10 and 12 is what we're looking for. So when we add up this side and this side, we needed to add up between 10 and 12. So I have a feeling we're going to have several of these this time. So 12, 12, 12. Yeah. 12, 12, 10. Not here. So it's going to be one of these 3. So let's just underline those for now. It's going to be one of those three. Which means, what does that mean? Where are we going from here? So let's just write down some information that we have from there. So, first of all, the top number is either 2 or 3. Right? Because it's going to be one of these three. Either going to be 2 or 3. It could still be either 8 or 10 because we have 1 10 as well as 12s. We still know that this is either 2 or 4 from earlier, so we could maybe try to do J, but that's a lot of additional variables in there, which I'm not psyched about. But I don't know that we have a more restricted path necessarily. Especially that would help with that. Let's actually color code that. That'll be easier. So, that cube is red. One of the red ones. Yeah, I guess let's do J, shall we? Because I think that's the best we got. So there's still going to be kind of a wide range of things. If we're lucky, well, I'll just do it. We're fine. So J has 10 plus either 2 or 4 plus whatever this is. So we have 19, 18, 14. So 19 or 14. So then we'll add up the high numbers, which gets us, wow, let's add up the low numbers, because that's 16. And the high numbers, 14. So that's 26 then. Great. So we've got 26 to 7 more than that. Yeah. So 26 to 33 is what we have already. So then we have just these two to fill in the rest. So if we're going to 42, so 2 minus equals, oh, what is that? I don't know what that is. Math is hard. 22, so 16 or 9. From 16 to 9. So 9 is conspicuous, so that'll be the front and the right side of these cubes. So this one has to be either one of these two. But this is where we can do a little bit of logic. So if, how do I explain this? So say this cube was here, then we'd have 14, 18, what am I saying here? You know what? Here's what I really want. I'm going to do this a simpler way, I think. We've got 10. We've got 2 or 4. So we've got 12 or 14. So 42 minus those is, wow, I keep forgetting that digit there, is either 30 or 28 left over. So these two and these two need to add up to in between 28 and 30. Basically what I'm saying here is that from all of our previous math, we know that this one specifically has to be either 9 or 14. But if we add both of those up, we don't get to this. So it's not, this red is not going to end up being the 14. I'm not confident this is making any sense at all. We know this is the 9, and we know that this isn't the 14. So I'm going to draw that in. 2, 5, 4. We can cross this out. We know this isn't the 14. So we're going to know that this is now 10. And this is either 8 or 9. Which we should be able to figure out now with specifics. So, okay, so you got 42 minus 10, 20, 9. So that's going to be 29 equals 31. 31? No. 13. 13? Now I have to double check. 13. Yeah, 13 is right. So now we need either 2 or 4 plus 8 or 9 to add up to 13. There's only one way that works out, and it's 4 and 9. So we can grab the small eraser. We know that this is 4. We know that this is 9. So if this one is 9, 10, there's only one that's 9, 10, so we can cross this out. We know that this is 3 now. We can clean up our work. So now we're looking at these 3 again. So we've placed both 4s. So now we know that this one is going to be 2 on its right side. The right side number is what we're looking at. So the 4s have been placed, so now we know it's 2. So both of these are going to be either 8 or 10. We haven't placed that yet, but we can, because now we have this all filled out. So let's do that, just because that'll get us a lot of numbers down. So I'm just adding up this row here from G to G. So I'm so lazy. Okay, so 3 plus 7 is 10, plus 15 is 25, plus 9 is 34. 42 minus 34 is going to be 8. It's not going to be 10, so it's going to be 8. Escape. So then we know this is 8. We know this is 10. What a terrible 8. Looks like a 6. There we go. And then we can cross out all 3 of these because we've placed them. So now we've only got 3 things left. Craziness. So what we're going to do is we're going to take a quick look over here, over both of these, this way first. Looking at C, it's all filled in except for top and right side of a cube. So if we look at the top and right side of the cube, cube and add them up, none of these are equal, which means that we can figure out with math for sure which cube this one is. So that's what we're gonna do. So we got 7, 7 is 14, 24 plus 6 is 30. So 42 minus 30 is gonna be 12. So we're looking over here for a top and a right that adds up to 12, which is this one. Ding, 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 we have a winner. So 2, 10, 8. Cross this one out. Nice. And now we've got only 2 left. So we get to pick whatever we want, essentially. I'm gonna do E to E next. So we've got 24 here, so 42, I'll write it down again, why not? Minus 24 is what? 18? 18. So now we need a front and a top over there that adds. So now this is 10, 8, and 9. You can cross this out. We only have one option left, so we know this is 10, 4, and 2. Nice. All right. I have no idea how this came across on camera. Hopefully this is all legible. That was good. Let's see if we did it right. I'd be very surprised if it's not right on this surface. 122. Yep, it's all right. We did it. Go team. That'll be it for this week. Next week, I'm thinking I'll do something musical. Depending on how the week goes, it'll either be finishing up Thorin's song or just playing something and uploading it. We'll see. I hope you enjoyed. I hope that made any sense. Thanks for watching, and see you next week.